Okay, this is a pretty basic problem here, right? 80 kilometers per hour is doing work against air, and it's doing work against resistance at a rate of 80 kilo or 40 kilowatts, right? How far will it travel in an hour? Well, I'll bet it'll travel 80 kilometers, right? Because it's 80 kilometers per hour. So hey, there we go, right? Okay. How much work does a car do against air resistance in an hour? Well, in this case, we know it's 40 kilojoules per second, right? And 1 hour is 3,600 seconds, right? So power is work divided by time. So work is power times time is 40,000 watts, 40,000 joules per second times 3,600 seconds. Right, so let's see if that works. Huh? 40,000 times 3,600. And I get 144, and then, boy, just a lot of zeros. There's 6 zeros. 1, 2, 3, 4, 5, 6. Let's see. 1.4 times, yeah, there it is, right? 1.44 times 10 to the 8th joules, right? Okay. So in 1 hour, it does that much work, right? Okay. If it's 75% efficient, how much energy must it get from the fuel? Well, the work output was 1.44 times 10 to the 8th joules, right? The input is what we want to find, right? Efficiency is output over input, right? So therefore, I guess, let's see, work input would be work output divided by efficiency, right? So it's 1.44 times 10 to the 8th joules, right, divided by 0.75. Let's see that. Divide the number on my calculator by 0.75, and I get 1.92 times 10 to the 8th joules, right? Okay, so that's that answer right there. Okay, I've got that on my calculator. All this will go away. Okay, if it's 45.8 megajoules per kilogram, how many kilograms of diesel will the car use? Well, we want to get that much energy, right? And so we're just going to go 1.92 10 to the 8th joules divided by 45.8. That's times 10 to the 6th because it's megajoules, right? That's joules, sorry, not mega, joules per kilogram. This will give us kilograms, right? So that divided by 45.8 E6, and I get 4.192 kilograms, which that must be that answer there, right? Okay. If the energy density is 0.9, energy density is 0.9 kilograms per, this must just be the energy of diesel. If the density of diesel is 0.9 kilograms per liter, how many liters will the car use? Okay, so density is mass divided by volume. So volume is mass divided by density, right? Okay. So the mass is 4.192 kilograms, and then we're going to divide by 0.9, and this is kilograms per liter. Divide by 0.9, and I get 4.657, or 4.7 liters would be right. All right, and then what's our final one? Calculate the liters of fuel used per kilometer. How many liters per? Well, there's 80 kilometers. We used liters is 4.658. All right, and then divided by 80 kilometers. Right, because we went 80 kilometers. So just divide by 80. I like these problems where you just keep the same answer on your calculator. And I get 0.058 that's liters per kilometer, right? The question, though, the better question is how many kilometers per liter you get, right? So that's 17.15 kilometers per liter, right? And that's not very much. Let's see, how do you turn, I don't know, kilometers? It's 17.1575 kilometers is not very much. So this is a very fuel inefficient car.